Thank you, Randall and JT. That was perfect in setting the stage and grounding us here in Wyoming. My name is Jennifer Petridge, and I am from Lawrence Livermore National Lab. I've worked at the lab almost 20 years. But I grew up in the Midwest, and I actually spent many summers here in Wyoming, believe it or not. I worked at the Safari Club International site out in Teton County. I learned to shoot. I learned to backcountry, do wilderness leadership, and I really love this state. It is wonderful to be here, so thank you for having us. What I want to share with you today is what we've learned in an analysis of carbon dioxide removal that was national in scale, but at every opportunity I have, I'm going to try and bring it down to the local to tell you about what this means for Wyoming. And then what I'm going to ask you to do is tell me how we got it right, how we maybe need to be a little more nuanced in our thinking because of realities that you know, because you live here. So Roads to Removal is the title of our report. You've got probably an executive summary sitting in front of you. This is the work of nearly 70 authors. You've got several of them here in the room today. But this report was commissioned by the Department of Energy. And as I go through, I'll show you all the different facets that we analyzed. But let me start by talking about the rationale. You just heard actually really good understanding of the rationale that's specific to Wyoming. But let me start at kind of the global picture. And that is that we have emitted more CO2 into our atmosphere than our planet can handle. And we have a situation where we have a change in climate and a change in weather. We also have changes in the quality of our air that we breathe, of our water. And all of those things are kind of wrapped up together. And moving to a more diversified energy portfolio is going to help what we call decarbonize, balance the sources of energy that we use as a country, as a planet, as a state. And as your governor has, I think, frequently said, an all of the above energy portfolio is healthy. For the state of Wyoming, it's healthy for the nation. It's just like when you're looking at your investment portfolio, you want to balance the things you've invested in, how much you've got in capital gains, how much you've got in other kinds of tax revenues. You want to think about all of that at the same time. So you have done an enormous amount of work, I know, in this state, looking at wind, looking at batteries, investing in new kinds of biochar, hydrogen. There's, I think at the university, you're probably doing almost more diverse work in this space than any other place that I can think of. But that is all kind of what we call above the zero line. And when we talk about net zero, that's the balancing of the amount of reduction of emissions with this carbon dioxide removal concept. That we've got, let's call it pollution, carbon pollution in our atmosphere that we need to remove if we want to get to a balanced system as a planet. And so that's what that green area below the zero line in the graph is. And that is net removing CO2 from the atmosphere and storing it durably. And storing it durably can be in a forest. It can be in soils. It can be in rocks that are a mile down. And that's really durable storage. And you have an amazing opportunity here in Wyoming to do that kind of removal. So those are what we're talking about here. Carbon capture and storage was mentioned, and that is very much part of the equation I recognize here in Wyoming. That's not going to be what I focus on in this talk. That's not what we did our analysis of. But I'm going to really focus on that green zone. Let's see if I can get my pointer oriented the right way, of the carbon dioxide removal. And the Department of Energy challenged us when we were setting out to do this analysis to ask, can you meet 1 billion tons of removal a year by the time we get to 2050? Not do the models say that that's what needed, but do we have the resources? The land, the water, the people, the biomass, does it exist in this country? And can we do this affordably? So that's really what we looked at. So we're, again, balancing the sort of all of above decarbonization with the real cleanup, essentially, of our atmosphere. So why did we have the chutzpah to say we could do this? There's over 3,000 counties in the United States. That's a lot of data to crunch. Well, we had been asked now 7 years ago by the state of California to do something similar, to find out what the capacity and cost for carbon dioxide removal would be for our state. And we wrote a report that was called Getting to Neutral, which was very influential, led to a bunch of changes in legislation and led to mostly just a conversation that was very healthy for our state. And we thought, let's try and do that for the nation. Let's give people the data that they can then work from to have those local conversations. So again, we brought together a team from all across the country, folks from Colorado State, from the East Coast, from Iowa State, from California, you name it. And 70 authors, give or take, put this report together. Experts in all the different facets of carbon dioxide removal, which I'll talk about more in a minute. We really wanted this to be cross-cutting, so we included some of the energy and environmental justice analyses that really had not been analyzed before. Who gets a job? Who loses a job? Whose water or air gets better? Who gets land? Who benefits financially? And then we also tried to be just as straight talking as we could. Let's not tell what the policy should be. That's for the local leaders to decide. Again, provide the data, provide the information, and then do what we're doing here today, be in conversation with you to think about what does that mean for policy on the ground here. So let me walk you through the different steps of carbon dioxide removal, because it's not just one thing, it's a lot of different ways to achieve this. But we start with carbon dioxide molecules in the air. And I like to joke that the OG of carbon dioxide removal are plants. They're trees. They're the grasses growing in our rangelands. Because photosynthesis is carbon dioxide removal. It's taking it out of the air and storing it in a molecule that might last for some time. Now, if we do that in trees, it can last for hundreds of years, except in our western forests that are becoming more and more likely to burn. So we know that that's not always a durable solution. In our soils, soil carbon is the biggest block of carbon, and it's bigger than what we find in the atmosphere and the biosphere combined. It's a huge, huge pool. But our agricultural systems writ large have lost a lot of carbon through tillage, through erosion, wind, stuff just running down the Mississippi. So we have to think about how do we increase that carbon, because it provides a lot of health for our soils. But then there are more technological solutions, and those might be the ones that Wyoming wants to focus on a little bit more. And those are taking some of the extra biomass that farmers might leave behind, or that municipalities in big cities are literally just putting in the garbage, or that we might even grow as a purpose-grown carbon crop, a switchgrass or a miscanthus crop in certain parts of the country. We truck that to a facility that's going to convert that to a useful fuel. Hydrogen is at the top of the list, sustainable airline fuels, asphalt, I could go on, there's a long list. But at the same time, they're doing carbon capture. Just like CCUS, you can do point capture at that point and capture that CO2 and inject it deep in the earth. And you're now doing geologic storage, so it means it's durable for thousands of years. And finally, direct air capture. You heard about that a moment ago. That's the idea that we literally suck CO2 at ambient concentrations out of the air. Great big fans working in reverse. And that carbon that we capture there, again, we can store it durably in geologic formations. We can also make some really interesting products with that CO2. Right now it's being used to make some of that's apparently, you can walk down a sidewalk in San Jose that's made out of captured CO2. There's a lot of other kinds of products and a lot of new innovation in that space because it's a really useful molecule. So that's all the different ways we can achieve carbon dioxide removal today. There's a lot of new stuff coming online. But let me kind of skip to the take-home message. When the DOE asked us, can we get there? The answer is yes. We can achieve 1 billion tons of removals by 2050. We can kind of do it, not easy, but we can achieve more than that, let's just say. It will cost real money. Our calculations suggest it's going to cost upwards of $130 billion a year. And I like to look people in the eye, Does that look like a big number to you? It is a big number. But I want to tell you some other big numbers. Last year, we spent $93 billion cleaning up climate disasters. Right now, as a country, we're spending 5% of our GDP on health-related illnesses that have to do with pollution and water pollution. So you balance those things. This is managing an invisible kind of garbage. Are we willing to pay to do that as a society? I have to think hard about that. Well, the flip side of that cost, which I also like to make a little joke that what else can you buy a ton of for $130? Maybe some sand or some rocks. It's a pretty good bargain when you think about it that way. But what it comes with is an enormous burgeoning of new economy and opportunities in that economy, new jobs, right? And often in energy communities that might be currently losing jobs or worried about that, at least in the future. It's often taking advantage of expertise that have been gained through the oil and gas industry because injection in the ground often uses the similar engineering know-how as extraction. So I'm going to encourage that the time is ripe now, regardless of who is in the White House. There is enormous bipartisan support for carbon dioxide removal. There are incentives in the tax code, and there are incentives in every state because folks realize the opportunities, not only for cleaning up the environment, but also, to be honest, just to make money, to make new industries happen. The things that we can do today, though, are working on our soils, working on our forests, getting those Class 6 permits approved. You have primacy here in this state, so you're ahead of the game in that sense, but getting it to actually happen. Some of the technological solutions are going to take real financial investment. Some of these facilities take millions of dollars to set up, and that's going to take time. And we can't always rely on the federal government to be doling out billions in grant money. So I think there's opportunities to think about other ways to fund that, to encourage the research that supports that scaling to happen more quickly. Because as this slide suggests, we can do some of these natural solutions now, but by the time we get to 2050, we ideally want to have some of the more technological solutions on board at a large scale. Now this is a plot of Greg Nemeth, who's a kind of an industrial economist, has looked at many, many different industries and how they tend to scale up. And I think you can kind of look at that S-curve as being similar to the one that we drew on the left-hand side here. And right now, we're down there in that very low part of the curve, the formative phase, where we need to prove the technology works with pilot plants. And you're doing that already here in Wyoming. Build acceptance in our communities. And acceptance comes with knowledge and understanding and partnership. And that's another real opportunity I see here in Wyoming, because you have communities that I would say on the whole are more interested than we have some places elsewhere in the country. And then establishing the scale-up needs. Starting small, but then expanding to the scale that we need is not a trivial process. But once you get an economy, a new industry moving, it starts to create its own weather, as it were. And what Greg Nemeth's analyses have showed that when we do that for carbon dioxide removal, and states like Wyoming are out ahead, there are others that will follow. So this is a plot that essentially talks about the costs and capacities, and it's complicated, but I wanted to mostly just show you that not all of those steps, all of those different approaches to carbon dioxide removal have the same cost or the same capacity. Writ large, this is for the whole country, and I think that you can see, if you're looking at across the x-axis, how many millions of tons of CO2 we can remove versus the costs, that doing things with forests and soils, those are cheap. Let's do it. But the capacity is not enormous in this country. It's important, but it's not vast. What is vast is the opportunity, is all these purple bars, to do biomass conversion and carbon capture, so what we call BiCRS, or biomass carbon removal and storage. That's Maybe not as big an opportunity, though, here in Wyoming, because the biomass availability is not as high as it is in some other states, particularly in the Midwest or in the West, where we've got a lot of trees we need to pull out of the forest. What you've got a big opportunity for is the direct air capture and storage. And that is also an important part of the puzzle, but I will note it is at the far end of the cost curve here. Per ton of CO2, it costs more. That said, we need to start on all of these now. No time like the present. So I'm going to step through each of these and tell you kind of the national picture, but again, try to bring it back to what's going on in Wyoming and what we estimate for the state. So in terms of how we can store more carbon in our soils, you're going to hear more about this from my colleague Allegra Mayer on the panel later on, but we really focused on 3 approaches: cover cropping and 2 different ways of planting perennials, or crops that live year on year on year. And cover cropping is not probably an appropriate approach for most of Wyoming, but perennials are. Prairie strips, having perennial trees, hedgerows that are around the edges of fields can prevent wind erosion, and that we've known since the Dust Bowl. And just that small amount of extra roots holding soil in place actually holds a substantial amount of carbon over time. So here is just an image of where we see the biggest opportunity. It's probably in the eastern counties for the most part of the state. And Allegra will go into more on what those different options are going to look like. But it's something that we shouldn't ignore, because even rangeland management done right can at least hold the line or increase soil carbon. Forests, again, is a modest opportunity. There are other states that have much more opportunity to increase forest carbon. But there are forests in the state that could be managed such that the carbon is increased. And this is planting trees, but also just managing the existing forests out there in the western part of the state a little better. And in a lot of cases, this is simply managing so that we don't have these destructive wildfires. And that's often thinning. It's counterintuitive that by pulling trees out of the forest, you make the forest healthier, and it gets better at capturing carbon. If you do that, if you're pulling a lot of biomass out of forests or out of even off of grasslands where you might be growing a carbon crop, I think the old-fashioned idea is, well, let's burn it and make electricity. Let's have a biomass plant. I want you to think hard about the value of those electrons versus the embodied value of the carbon in that material. The carbon is worth 5 times as much in terms of energy creation. And if you take that biomass and pull it to a facility where you can do a gasification, a hydrolysis, many different processes, I'll talk more about those more in a second, you make a fuel that you can sell to offset the costs. But again, you can capture that carbon and store it. So this is just telling you a little bit about the tons of carbon that could be captured here in the state of Wyoming. Again, here, it's a modest opportunity. I don't want to oversell this. There are other states in the country where it's a bigger opportunity. But we can look at lots of the different ways to convert that biomass and remove CO2. We've got colleagues here from Charm that are making bio-oil. You can use it to make hydrogen, as I mentioned. I think that the hydrogen economy is going to grow as a part of our energy portfolio. Make biochar, which is often used as a soil amendment. It's a very long-lived carbon storage molecule. And then again, certain kinds of lumber, certain kinds of airline fuels can all come from converting that biomass. It really depends on where you are place-wise and what the types of biomass are. But writ large, across the country, this is actually the biggest opportunity space. It would take putting up a huge number of new facilities, though, refineries. And something like 300. And each of these is going to cost, let's say, $500 million. That's a huge amount of investment. Right now, seeing how we get from here to there is blurry. I'll be straight with you. And that is, again, something that I don't know that Wyoming is going to focus on as much, but this is at the national scale, something that we've been thinking hard about. There are facilities that are started up. You're looking at a couple here, one in Indiana that we were just close to a couple weeks ago, and then we have one in California. But there's real need for more technological innovation in this space. So I guess I'm speaking to those of you in the research and the university space that understanding how to scale up these technologies is really needed. But I want to talk to you mostly here now about direct air capture, because I think that's the real opportunity for Wyoming. And I'm not going to spend a lot of time talking to you about the biochemistry, forgive me, the physical chemistry of how this is done. My colleague Simon Pang is going to go over that more this afternoon. But again, essentially you're using a fan in reverse as to suck ambient air over either solvent or sorbent that actually captures that CO2 molecule. But then the tricky thing is you need to desorb that carbon dioxide so that you can concentrate it and inject it somewhere or use it. And that desorbing process takes a lot of energy. It's expensive. And we know that we have limited energy in this country as it is, especially in our electric grid. So we were really careful when we thought about where does it make sense in the country to do this. We wanted there to be purpose-built renewable energy, if possible, or natural gas energy to drive this process. Because we got a lot of places, a lot of counties in our nation that are already struggling, having brownouts because there is not enough electric power. We have these new data farms, you hear about it all the time. They're new sinks, let's say, of energy that are just going to grow and grow and grow as our population grows. So we don't want to steal from the existing grid. Wyoming is a place, though, where you have the opportunity to have abundant renewable energy that's purpose-built for direct air capture. And we did that analysis using this Sankey diagram is meant to kind of walk you through our thinking process. But we took all the counties, all the land in the United States, if you start on the left-hand side, and we categorized it, whether it was vegetated, whether it was wetland, whether it was national forest or urban. And we slowly stepped through ruling out those hectares. We're not going to put up a direct air capture facility on a national park. We're not going to put it in the middle of a city. We're not going to put it in a wetland. We're not going to put it in somebody's farmland. There are a lot of places we're not going to put it. We're not going to put it where we don't have that renewable energy. So what you get down to as you walk your way over to the right-hand side of the figure is only about 1% of the land area in the United States that is what we consider truly appropriate for direct air capture with renewable energy. But that 1% is largely centered around this part of the country. And you can see that Wyoming is, it's shades of blue and green there, and those blues and greens tell you about both the capacity, but on the cost. The costs are relatively low in the grand scheme of things, $200 a ton, something like that. But the whole state really, we determined, has that opportunity. It's an ideal spot. And that goes down through the sort of western part of the Rockies down into the Gulf states. But the other thing that makes this region really unique is if you were to do direct air capture, you have the geology to store that captured CO2 right where it's captured. So yes, there will be a need for pipelines, and Randall mentioned that, but here you could get away without them. And we know that pipelines can be politically difficult because of the eminent domain questions. So you could have purpose-built renewable energy right next to the capture, right next to the injection. And that is a really unique sort of sweet spot that is what makes Wyoming special. And in particular, some of these counties that we've highlighted here, Sweetwater and Campbell and some others. So geologic storage, we also evaluated where in the country that exists. The map you're looking at here, anywhere that's dark green is excellent for geologic storage. And you can see Wyoming's a little messy in terms of geology. There's definitely the Powder River Basin and some other areas that have excellent opportunities for storing CO2 a mile, mile and a half down. These are formations that are going to have tiny, tiny little crevices in between mineral particles that will hold that CO2. It will eventually mineralize over time, but they're overlain by a shale kind of cap rock that holds it in place. So you put one of these special type Class 6 wells that drills down into these formations, and you can inject millions of tons safely. And that, again, is a unique opportunity here in this state. Nationwide, we've got somewhere between 20%, maybe up to 40% of the nation that has that opportunity. But again, here in Wyoming, you already have enough wells that have been previously drilled that you actually know the geology very well. And so you're ahead of the game in that respect. The other thing that I'll say is we calculated not just the sort of in a two-dimensional way of where the geology is correct or appropriate for injection of CO2, but what's the total volume? That volume is large in Wyoming, and your costs for maintaining one of those wells over time are going to be relatively low. In some cases, we're talking $4 a ton. That makes you competitive, but in some cases more competitive with the Gulf region, which I think is often, well, they tout themselves as the ideal place for doing this kind of procedure. You've also got the know-how in your communities in terms of, you've done a lot of previous oil and gas extraction. So that's the map of ideal locations in the state of Wyoming for geologic storage. So I'm going to wrap up here by just talking about what are some of the community pros and cons, and that's our analysis of the economic, the energy, and environmental justice elements. When we want to think about CO2 removal, we need to think about trade-offs. That's true for any new industry. And so there are risks, there are benefits. When we think about the risks, that's changing land ownership, that's changing who wins in terms of the economy. It's thinking about what small businesses are going to win or lose. When we think about the benefits, cleaner air, the new jobs, investment in our public lands, cleaner water. Lots of them. I could keep going. We looked at 27, 24. Anyway, I may get the numbers right, but Kim will correct me. Different indices which are reflective of those pros and cons of carbon dioxide removal. And ones that I thought might be relevant here in the state are just simply the sort of social vulnerability index, and that's a balance of what's somebody's take-home pay versus their health score. How are they doing health-wise? How long are they living? We looked at soil erosion. That's something that's particularly important in the Midwest, but it can be important out here where you have really high wind as well. And then the energy communities, places where we're losing jobs and have the opportunity to gain those jobs back in industries where people already have the right skills. And Wyoming is really a center for that opportunity. So what the overall take-home of our report suggests is there are different regions around the country that have different opportunities. There is not a one-size-fits-all. We like to say that every region has a story and an opportunity. The opportunity here in Wyoming, if I didn't make it clear already, is in direct air capture, it's in geologic storage. There's a certain amount of forest and soil management that also makes sense. Now, what do we want to get out of the rest of today and hopefully an ongoing conversation? Well, we are already invested in communities here. There's a community that we've been, a small cohort of folks that Kim has been in conversation with to tackle one of the hardest parts of carbon dioxide removal, and that's the monitoring and reporting and verification that it's being done and done right. And MRV, as it's called in the industry, is a really thorny issue. We don't have an overseer that everybody trusts right now. We don't even have a framework that everybody trusts. So we're in the midst of facilitating dialogue with different communities around the country, and this, you can see the little yellow circles there to folks in Alaska and California and elsewhere, and with tribal groups as well, about what should those rules and regulations look like? Who should be at the table? Who should be overseeing this new industry? And so that's been funded by the Department of Energy, and we're about halfway through that process right now. We are also looking at how we can collaborate with industry and, again, with communities and kind of form bridges to involve communities and in the community benefit plans that are now required by the Department of Energy. So anytime they are investing in a new project, like the carbon safe projects that you have many of here in the state of Wyoming, the Department of Energy requires that there be a certain amount of that money that's going into the community for the community to be engaged with that project, to understand what's happening, and to have a voice in how it happens. And our team has really become expert in facilitating that interaction. We've also been just simply training communities to understand what is geologic storage, what is direct air capture. A lot of that work that we're involved in right now is happening in California. We're excited to work with you as well. And we want to be seen as a resource of that information and that community building. So I'm going to wrap up there and thank again the team that has helped me put together this report. It's kind of like a book. It's 500 pages, so I'll warn you. Choose the chapter that you're most interested in and maybe start there, or choose the executive summary. Come and ask one of us, and I am happy to take a couple questions if we still have time. Thanks.
Any questions? Just raise your hand. We'll bring you the microphone. Yes.
Thank you, and great presentation. The question I have is with DAC. Did you look at elevation, humidity, things like that? Because obviously that can play a challenge here in Wyoming with our elevation and our dry climate that we have.
Right. I want to defer to my colleague Simon Pang, who is an international expert in those specific questions, how humidity and particularly temperature affect direct air capture. Can you say some things? I don't know if we can get a microphone to Simon.
That's okay.
Yeah, all right, good. Yeah, it's a fantastic question. I guess what I'll say is that there are a lot of, so we talk about direct air capture as kind of a technology, but really it's a class of technologies. And so there are going to be some versions of it that wouldn't work well in Wyoming, and there are going to be some that do. And so I think kind of where the science is at right now and where a lot of startup companies are is trying to figure out what are the climates that my specific technology will work really well in. And so, yeah, so it's an ongoing problem. It's a really great question. And so, yeah, there are going to be some that are going to be excellent for Wyoming that would be terrible in the Gulf, and vice versa.
But in terms of what went into this report, that I'll remind you came out almost a year ago, we did not put the level of detail that we might have even put today, because this field is moving so quickly because of labs like Simon's. So I would argue there's a lot more to be done in that space. We just scratched the surface in terms of including those kind of weather variables. Yeah.
I'm looking at figure ES13. I read the executive summary. On your down selection of suitable land and
Yes.
and breaking down, just curious what percentages of the far right are federal, state, or privately owned managed lands? Or if that was part of the consideration.
There we go. So saying which one part of the part over here, the protected?
Yeah, going probably to the far right, carbon removal, the smallest category. How of those lands, hectares, what's the ownership management breakdown of those?
The majority of those are either in private. There is some, I believe, federal land that is would be appropriate for a wind farm. The federal lands that we ruled out are protected as national forest or national parks. If it's BLM lands, that was fair game. Again, I'm looking to my team to see if there's any other nuance, but I think that, is that answering your question? So there's some federal in there, there's some private in there, but there's nothing that, I'll just be straight, that the Nature Conservancy would cry about. It's not protected in a status where we wouldn't want to be comfortable putting a well or putting up some wind farm.
That was a good transition to my question, actually.
You're probably from the Nature Conservancy, and I'm going to have to hold my head.
No.
All right, somebody's here who's going to call me on that.
But I actually represent large numbers of landowners,
Yeah.
and actually represented about 500,000 acres of landowners who did a transaction like this. One of the things we've seen as kind of a struggle sometimes, though, is when it comes to community outreach, you often have a lot of outreach that goes to the cities. Or
Yep.
it goes to, when we say community outreach, it's to cities and the people who actually don't have the on-the-ground effects of the project. How do you guys envision reaching out to landowners and those who you need their land to be able to make this successful?
I think that when I talked about scaling, that is a critical piece. So it's not just about industry scaling up, it's scaling up parcels of land at the level where a project makes sense. I just this morning read about a group of landowners here in the state that are, those are your guys, all right, who are collaborating together. These are ranchers who, as mentioned earlier, you don't make money every year running cows. But if you could farm carbon deep and shallow, then maybe that would be a more renewable and reliable revenue source. But you got to get to hundreds and hundreds of acres to make it really make sense. And so I agree with you. We need to find ways of reaching out to those communities. There still are organizations that represent folks who are in rural spaces. And I'll give you one example from California. We've got a number of landowners in the Delta region up near where I live in the Bay Area who came together, and they've been thinking about pore rights, and they've been thinking about storing carbon deep within the earth. But then they realized, well, we're all farming in a climate where we don't have enough water because we've had drought upon drought in California. We have so much sun. How about we put up solar panels above our crops, what we call agrivoltaics, to actually protect the crops from too much sun, so the crops actually hold the water a little bit better. We can make electricity, we can make a crop, and we're storing carbon below ground. We got 3 revenue streams all of a sudden. So I think, again, you'd need a number of landowners to come together to make a project like that logical. You're not going to do that on just 100 acres. But what you spoke to is, how do you bring those communities together? I would invite you to start to tell me the answer there, because I'm not entirely sure. I live in a more, even the Central Valley is more densely populated than here in Wyoming. Yeah. Okay, let's talk about that later on. Yeah, we have another question here, I think.
Can you guys hear me okay?
Yeah.
Awesome.
That's it.
All right. I don't really have a question, but I wanted to introduce myself and my company. So my name is Mindy Ren. I work for Spiritus. Spiritus is a carbon removal company specialized in DAC, direct air capture. And guess what? We are coming to Wyoming. We're coming to central Wyoming. We are looking to partner with the renewable developers and utilization companies. So if you are in that space, come to talk to me. Very excited.
Great. Thank you for doing that. Thanks for letting us know. Other questions, comments? JT, I'd love to hear from you. All right. Sorry, we're going to take one in the back, and then maybe JT's next. Yes.
I'm concerned that we're getting horizon creep. For example, you're talking about 2%, 2 degrees Celsius by 2050. 1.5 is the cutoff point scientifically, and we need to hold that. We're there now already, according to COP29 today. So looking at 2050 instead of 2030, COP29 says if we don't meet a 45 to 50% reduction in our carbon emissions, we're gone. So 2050 is 20 years beyond. Mm-hmm. For most of you, you may still be here. I probably won't be. But also, I'm concerned, it does matter which administration is in. In this state alone, the 2 senators and the 1 representative regard this as a hoax. The incoming president regards climate change as a hoax. I don't see where there's really an opportunity to save us from disaster.
Well, I'll be straight that I usually start my talks with a very emotionally wrenching video that says later is too late, because the effects of climate shifts and weather shifts are already happening. And they're affecting certain parts of our country more acutely than others. Florida, obviously, gets hit by these hurricanes, it seems like every year. We're seeing it in California in terms of the droughts. But you're feeling it here in the air pollution from the fires, whether the fires are happening here or they're happening further west. So we are in an emergency situation, in my opinion. But not everybody feels that way. And we need to be able to move forward without somehow resolving that debate first. We're not going to. We're not going to convince our incoming president that what the COP says is, he needs to follow their policies. It's not going to happen. We need to be pragmatists. And so I see the opportunities I've presented to you and the things that you're already doing in the decarbonization space, in the carbon capture and storage, as the steps that need to be made in the near term. And again, I want to remind you of that S-curve of the economy growing at an accelerating pace, at an exponential pace. If we start to move this economy in that direction, it will accelerate. Will it happen fast enough to keep us at 1.5 or even 2 degrees of warming? I would say, as a scientist, I would say no. We are already past 1.5. I don't even use that number anymore in my talks. But we have an opportunity to preserve jobs, to preserve livelihoods, to do the best we can. I think that's what we have to aim for. JT.
Thank you. Yeah. So I just came down from Casper from the state legislature Select Water Committee, and we were having a discussion around forest management and the benefits of decreasing the density, not only for watershed, but also to help prevent with the mass forest fires. We just went through a tough fire season here in Wyoming. We're trying to address that. But I guess I'd just like you to drill down a little bit more into that scheme. Have you looked at the benefits of decreasing density of forest compared to the forest fires that we have? I mean, what are the costs? What's the cost analysis there?
Yeah, so that's actually exactly what we did. And I didn't spend a lot of time on that because the numbers are not enormous for the state of Wyoming. For the state of Oregon and Washington and Northern California, they are. And that's just about the amount of land that's covered in forest. Removing anywhere between 20 to 35% of the stand can make the stand healthier, less likely to burn, and actually more able to grow because it's not burning. It's just that simple. It's also less likely to be attacked by bark beetles and other kinds of diseases that have an accelerating effect on forest fire risk. So you know this, that we've had a forest management policy that's kind of been hands-off in the last 100 years in this country. And I would love to see a coupling of some of the thinning activities that could happen, especially on our federal lands where it's legal to do that, with this biomass conversion, because if that biomass, again, is valued as something more than just firewood or biomass wood for electricity, but we actually see gold there that we can produce hydrogen or some of these other products, then I think the economic proposition works better. Because right now, to go out and thin an acre of land can cost $1 million. It's incredibly expensive. There are companies that are developing equipment, robots, for lack of a better word, that require less humans because it's dangerous work, especially on some of the landscapes you have here. So I think that space is going to change, but it's one of those near-term opportunities that we could start on in the next few years. And whether we're doing it for climate reasons or fire reasons or the beetle, you pick your reason, water management, all of them, everything benefits from taking care of our forests in a more sustainable manner. Hi.
Yeah, hi, and I just wanted to speak to Representative Larson again on that question and let you know that the Nature Conservancy has a program that focuses on forest management. We've published some reports that are very in-depth on exactly the question that you're asking and that we're being answered here. And we would love to talk with you more about how to enact some of these things on the ground.
Yep, thank you. I feel like I saw one in the very back of the room.
Time for last question.
Okay.
I'll make it a good one.
Okay.
Where are we in terms of the economics here? We build, 1,000 DAX systems. What's it cost to run them versus the trade-off on what's the outputs for energy to get them going versus the inputs? What's that look like? If you looked at that at all?
It's a good question. So I know the numbers for putting up a biomass plant better than for DAC. For biomass, the facilities that I've spoken to, it's about $500 million to set up the plant. And that's a one-time cost. The other costs are all factored into our numbers, and we're looking at something on the order of $60 to $80 a ton of removals. But this is currently a $2 billion industry, carbon dioxide removal. By the time we get to 2030, certainly by the time we get to 2050, it needs to be a $200 billion industry for all of the economies of scale to work. Now, again, apologies, Simon just stepped out of the room. He might be able to tell you more specifically what Heirloom and some of the other companies that have a pilot plant have spent on putting up their facilities. I would say none of those facilities are operating yet on anywhere near the scale that we need. I sometimes am in a room like this and people say to me, but these guys are removing 1,000 tons a year. We need to add 3 zeros to that. You're right. They're absolutely right. But this is, again, a scaling issue, and the financing is part of that scaling. So I'm sorry, I'm not giving you a super straight answer, but I think Simon will be able to add a little bit more nuance, but I think there's more analysis that needs to be done on how to kind of start to get up on the steep part of that cost curve. Yeah. All right, Susan's telling me we're done, but so thank you all. I appreciate the great questions. Bye.